बच्चों, क्या हालचाल है? हाउस द जनता? नाइस. वेलकम बैक. एंड सबसे पहले तो थैंक यू एवरीवन फॉर द अमेजिंग रिस्पॉन्स ऑन द लास्ट वीडियो. It was such a delight to go through all the comments and find out that you actually enjoyed the video a lot and you learned something as well. Okay, so let's continue with it. गाड़ी आगे बढ़ाते हैं. So for the first timers, I am Gaurang Sir. I'm the physics master teacher at Vedantu. I did my graduation in architecture from IIT Roorkee and I have been teaching since then. So I've been teaching from last 10 years. And I have mentored more than 12,000 students, including top 10 AIRs like AIR 2, AIR 3 in JEE as well as medical entrances. So that was about me. Let's start with the session now. So what we'll be doing today? Today we'll be continuing with Vectors 2. Okay guys, before we go ahead with this topic, those who haven't attended the last topic, please go through the session. It will be very helpful. Actually it's all linked as you all know. And those of you जिन्होंने attend तो किया था but sir भूल गए हैं, एक quickly we will have a recap which I used to call, let's have a Maggie recap. 2 minutes Maggie recap. So what did we studied in the last session, in the first session of the vectors? First of all, we discussed what actually are vectors. Okay, we discussed about physical quantities, then we divided physical quantities into scalar and vector. Now, if you remember about vectors we talked, vector should have three things: magnitude, direction, and the third important point which most of the students miss is it should follow vector laws of addition. Remember? After that, we had some examples of scalar quantities and vector quantities. Okay. And what did we study after that? After that, we studied types of vectors. Okay. So different type of vectors that we studied were equal, opposite, and the third one was coplanar. Remembering guys, कुछ याद आ रहा है? Okay, that's good. Now, one thing important I mentioned in the last session regarding coplanar vectors. Guys, vectors have an important property. What is that? If you move a vector parallel to itself, there is no change in the vector quantity. Okay, I'm laying emphasis on it because we'll be using this property a lot in this session. Okay, so hopefully सब कुछ याद आ गया. Now let's continue guys. So we were talking about the types of vectors: equal vectors, opposite vectors, coplanar vectors. Now guys, there's an important type called unit vector. Now what exactly is a unit vector? Unit vector, in very simple terms, it only represents the direction of the vector. Or in other words, a vector having magnitude 1. Okay guys, there's no unit associated with it. It's single one, unity. Okay. And having any direction is called a unit vector. Got it? And if you remember the representation of vector, we do it by a quantity A and an arrow on the top of it. It represents the vector quantity. Now, as we all know, a vector quantity consists of two things: a magnitude and a direction. Okay. So, the magnitude of this will be mod A. Remember, when we keep it between mod sign, it becomes the magnitude, and the direction will be represented by A, but topi pehna do. Okay, it's pronounced as A cap. Following me guys? Now if we try to write the two components separately, the two components means the magnitude and the direction. The original vector A vector will be written as mod A into A cap, the direction, From here you can obtain the unit vector itself. Unit vector will be simply a vector divided by its magnitude. Guys, some example also we did in the last class. Let's say a body is moving with 60 kilometers per hour towards south. Now it's a vector quantity. 60 kilometers per hour is the magnitude. South is the direction. So this A cap, it represents only that south direction. Following it, guys? Okay. This unit vector is also very helpful to us. How come? We just discussed this. If you know magnitude of a vector, if you know direction of that vector separately, you can multiply them and you can obtain the overall vector quantity. Chamka, guys? Following everyone? So let's go ahead now. So let's summarize it. If you want to find unit vector for any vector, okay, you want to find the direction, simply divide the vector by its magnitude, and what you will obtain is unit vector. Remember, representation of a unit vector. Whenever you see this cap, topi, that means it's a unit vector. Following it, guys? So this was about unit vector. We have another important type of vector called zero vectors. Although not much used, but let's understand what it is. A vector having zero magnitude and undefined direction is called a zero vector, or there's another name for it, null vector. How is it represented? As you can see here, it is represented as O cap. Okay. And unfortunately, it cannot be represented graphically. Why? Because it is having a zero magnitude. Since the magnitude is zero, you cannot draw an arrow to represent it. Got it? So this was all about the various types of vectors that we'll use in physics. Now coming to the important part, addition of vectors. The major problem was that apart from having direction, it follows vector laws of addition. Okay. So suppose you are given different vectors, and let's say they are in the same direction. You can very easily add them. How? You walk 5 meters in a particular direction, then you walk further 1 meter in the same direction. Very easily you can say the total displacement will be 6 meters. Everyone following? Displacement, if you remember from the last session, it's a vector quantity. So it's a common sense. Same direction में अगर vectors है, you can simply add them. If it had been in the opposite direction, 5 meters you walk in a particular direction and you walk 1 meter back, then from the initial position, the displacement you can say is 4 meters. That's also quite obvious. Okay. Another example for this. Suppose there's a box lying and you apply 20 Newton force from one side and you apply 5 Newton force from the opposite side, in the opposite side. Then very obviously you can say the net force F net will be 15 Newtons. Okay. So if vectors are in the same direction or they are in the opposite direction, we can very easily add them. But what happens if the direction of vectors are different? Okay, so let's study them. For that, we have various laws. Okay, laws of vector addition. We have actually 3 laws. Triangle law, parallelogram law, and third is the polygon law. Okay, so these 3 laws we have for vector addition. Let's focus on the first part, triangle law of vector addition. Now guys, remember for your 11th class, many a times this question is asked in a form of 2 mark or 3 mark question. Okay, so you will have to remember the statement as well for your board 11th school exam. Now, what's the statement? Let me quickly read it, then I'll explain it. When two vectors of the same type are represented in magnitude and direction by two sides of a triangle taken in a certain order, clockwise or anti-clockwise, then their resultant vector is represented in magnitude and direction by the third side of the triangle taken in opposite order. And guys, unfortunately, you will have to memorize this exact statement for your school exams. There's no escaping from that. Okay, so now let's understand the statement. Let's mark the important words here. First condition is of the same type. This is very underrated but very important. Why? Because only you can add vector or physical quantities which are of the same type. You cannot add displacement in force. 5 न्यूटन का फोर्स लगा, 10 मीटर्स का डिस्प्लेसमेंट हुआ, टोटल कितना हुआ? नॉट डिफाइंड. ओके, 5 न्यूटन का फोर्स है, 10 न्यूटन का एक और फोर्स है. नाउ रिजल्टेंट यू कैन फाइंड आउट. सो फर्स्ट इंपॉर्टेंट पॉइंट इज द सेम टाइप. Represented magnitude and direction, that we all know, by two sides of a triangle taken in certain order. Taken in certain order, what does it mean? It means if this is the first vector and this is the second vector, on the head of the first vector, second vector should come. The tail of the second vector should be on the head of the first vector. Then they are said to be in order, like this. Okay, in a continuation sort of way. In that case, the resultant will be given by the third side of the triangle taken in opposite order. Guys, understand the diagram here. Pay attention. First vector and second vector are the ones we needed to add. The resultant is given by the third vector, and you can see the resultant is in opposite order. Following guys? कुछ confusion हो रहा होगा, I think. Okay, let me explain it in a different way. Suppose we have two vectors. This is A vector and this is B vector. And we want to find a third vector, C vector, which is actually sum of these two vectors. And we want to do it by triangle law. So what does triangle law suggests? First of all, let's keep A vector as it is, no confusion there. B vector we should take in order. What does taking in order means? पहले वेक्टर के हेड पर सेकंड वेक्टर की टेल आनी चाहिए. Can we do that? Obviously we can do. Why guys? Remember the property. If a vector is moved parallel to itself, it has no effect on the vector quantity. So what actually we are doing is, we are moving this vector B vector such that इसकी टेल इसके हेड पर आ जाए. Got it? And now, what does the triangle law say? The resultant will be given by the third side. Okay, let's draw the third side first of all. This is the third side. But what does the statement say? Resultant is given by the third side of the triangle taken in opposite order. That means the head should be here. Okay, if C is also in order, the diagram will look something like this. This is A vector. this is B vector, and this is C vector. Okay, in this case you can see all the three vectors are in order. क्यों? एक के हेड पर अगले की टेल, अगले के हेड पर थर्ड वाले की टेल, and so on. So we are actually not talking about this. The resultant should be in the opposite order. Guys, everyone following? Clear हो रहा है सभी को? That's wonderful. Okay guys, one more interesting thing. The vectors follow an associative law. Means, suppose we are writing A vector plus B vector. But if you say, no sir, we don't want to do this, हमें तो B vector plus A vector करना है. Let's check it. Let's draw the B vector first. This was the B vector. Let's move A vector. This is A vector taken in order, and the resultant is given by the third side of the triangle taken in opposite order. Okay, so actually A vector plus B vector or B vector plus A vector, it's one and the same thing. Following it, guys? Good. Chamka, everyone. Okay. Now, one important confusion which most of the students have is angle between the two vectors. Now, guys, angle between the two vectors are defined when the vectors are joined tail to tail. Okay. Suppose this is A vector. Let's say this is B vector. And if I mention that angle between A vector and B vector is theta, so to denote that angle theta, you will have to draw these vectors or join these vectors tail to tail. This is A vector, this is B vector, and the resultant is, the angle between them is theta. Got it, guys? Everyone clear? Something like this. A vector, B vector. You join them tail to tail, and then you can define the angle between them. And obviously the angle will always be between 0 and 180. अगर ज़्यादा हो गया, so opposite side से ले लो. Everyone following, guys? चमक रहा है? Clear हो रहा है सभी को? That's good. Okay, let's proceed now. So, sorry, the triangle law that we talked about, this is the resultant vector. Okay, they are denoted by R vector. So, R vector equals to A vector plus B vector. For that, what do we do? You can write A plus B vector, or you can write B vector plus A vector. It's, as I explained, it's one and the same thing. Clear it, guys? Let's have a question now. बहुत देर थ्योरी पढ़ ली, कुछ क्वेश्चंस हो जाए. ओके, डायग्राम इज गिवन इन फ्रंट ऑफ यू, एंड बेचारों का डिग्री का साइन गड़बड़ हो गया है. द डिग्री का सिंबल सिर पे से नीचे गिर गया है. ओके, सो P vector, Q vector and R vector are mentioned like this. Okay guys, we are not talking about triangle law at all right now. What we are talking about is find the angle between P vector and Q vector and Q vector and R vector. Okay. And now let's solve it. As you remember, for finding angle or for defining angle between two vectors, what do we do? P vector, shift Q vector such that the tail is joined with P vector. थोड़ा सा गड़बड़ हो गया, भावनाओं को समझो. the angle between P vector and Q vector will be 90 degree. Now you must be thinking, अरे सर यहाँ पर भी तो 90 ही दिख रहा था, क्या दिक्कत, क्या इतना करने की जरूरत क्या थी? Guys, here it was a coincidence that head और tail जोड़ने पर 90 बन गया. It is not always necessary ऐसा हो जाए. Example, Q and R के बीच में देखो. If you observe in the diagram, what will you see? Okay, Q and R, the angle between them is 45, but 45 is the wrong answer. How? To find the angle between Q and R, we will have to shift one of the vector. Okay, what we'll do is, let's shift Q vector above so that uski tail yahan par aa jaye. Okay, how come? This was the R vector. Let's say this is the line of Q vector. Q vector we are shifting vertically upwards. Parallel we can shift, we have discussed. उससे वेक्टर पर कोई फर्क नहीं पड़ता. So Q vector can be shifted something like this. Now identify, this angle was given as 45, but it was not the angle between Q and R. Angle between Q and R will be defined this one. And what will that angle be? 135 degrees. Chamka guys? To define angle between two vectors, always join them tail to tail. Clear guys? Following everyone? Okay, so these were the answers that we were getting, 90 degree and 135 degree. एक और क्वेश्चन हो जाए. अब कुछ कुछ चमक रहा है, मजा आ रहा है. इनफैक्ट क्वेश्चन करो तो फील आती है, राइट? कि हाँ हमसे बन रहा है. थ्योरी पढ़ते पढ़ते तो सर बचपन से थ्योरी ही पढ़ते आ रहे हैं. Okay, there are two vectors, f1 vector and f2 vector, and now you have to find the angle between these two vectors. Again, ऐसे तो एंगल नहीं डिफाइन कर सकते. एंगल डिफाइन करने के लिए क्या करना पड़ेगा? You will have to join them tail to tail. That's the most important condition. So एक काम करते हैं. See, this was the original diagram. What we are doing is, we are shifting F1 forward. F1 को ऐसा का ऐसा आगे ले जाते हैं. F1 को अगर आगे ले गए, this was the original line, this angle was 37, but now the vectors are joined tail to tail. What is the angle between them? If this is 37, this will be 143. So angle between F1 and F2 will be defined as 143 degrees. Clear guys? Everyone following? चमक रहा है? That's good. So this was triangle law of vector addition. Now guys, before we go ahead, one important thing, triangle law of vector addition is usually used only graphically. Graphically means, okay, let me add a slide here. Okay, only when you are solving, the vectors are given in the diagram form, then majorly we use triangle law of vector addition. C vector equals to A vector plus B vector, or if you would have shifted A vector, it will also be equals to B vector plus A vector, one and the same thing. But still we are not actually finding the value of C. Value means the magnitude. Let's say I give you that mod A is 3 units, whatever be the units, this, let's say newtons, suppose. Mod B is 2 newtons. Can you tell me the magnitude of C, the resultant, from this triangle law? No. We have not yet discussed the magnitude part. Why? Because for magnitude, we do not prefer triangle law at all. We prefer parallelogram law. Now guys, parallelogram law is actually very important in this sense, because here we obtain the magnitude of the resultant also. So what is parallelogram law of addition? Okay, let us again go through the statement first. What's the statement? If two vectors, again important, of the same type, displacement है तो displacement में ही ऐड करोगे, force है तो force में ही ऐड करोगे, acting simultaneously at a point are represented in magnitude and direction along two adjacent sides of a parallelogram. Okay, now here's a twist, here's a difference from triangle law, that they are represented by two adjacent sides of a parallelogram. Then their resultant vector is represented in magnitude and direction by the diagonal drawn from the same point. Got it, guys? Let me explain it. In the diagram here you can see, although the diagram is a bit गड़बड़, थोड़ा सा resultant ज़्यादा लंबा हो गया, don't worry, we'll draw it again. Let's say this is the first vector, A vector. This is another vector, B vector. Now guys, can you see the difference here from the triangle law? In triangle law, we used to take them in order. एक के head पर अगले की tail. But in parallelogram law, we join them tail to tail. Okay. And what about the resultant they are saying? First of all, complete the parallelogram law. It would be something like this. And the resultant is given by the diagonal of this parallelogram starting from the same point. R vector. Okay, so R vector will be equals to A vector plus B vector. Following everyone, guys? This is the parallelogram law. Now guys, let me tell you something very interesting about triangle law and parallelogram law. So in your school time, sometime you must have done this, that assignment submit करने का time है, your assignment copy is not complete. What you do is you copy your friend's work, make some changes in it, and you submit it under your name, right? So triangle law and parallelogram law are something like that. Let's say A vector and B vector. The two vectors are given and you have to add them. So one of the scientists, what he thought, that okay, I'll add them by triangle law. A vector, B vector is taken in order, and the third side of the triangle taken in opposite order gives the resultant. So far, so good. Now other scientists wanted to do something different, but he didn't have any idea. So what he did, he developed parallelogram law. How? A vector, B vector, two adjacent sides of the parallelogram. The resultant is given by the third diagonal of the parallelogram. Okay, but if you observe carefully here, this vector is A vector. If it is shifted parallel to itself, it will be also A vector. This one is B vector. If you shift it parallel to itself, this will also be B vector. Now guys, focus on this part. What does it look like? This is nothing but triangle law in disguise. So एक का assignment दूसरे ने copy करके थोड़े से changes कर दिए. Okay. So diagram wise, parallelogram law, triangle law has no significant difference. Okay. But one important thing that we discussed was parallelogram law has importance because we can find the magnitude of resultant as well. Got it, guys? So now, how can we find the magnitude of resultant from parallelogram law? So to study that, you will have to join in the next episode, just like in the famous TV series like GOT, if you are following. They always end the episode at a very crucial stage. So you're pondering what will happen next. How will you do it? So similarly, we'll for the magnitude part, join me in my next session. There we will discuss it. Okay, guys, I hope you enjoyed today's session and you learnt as well. I would love to see all your comments, all your likes, all your dislikes, whatever you feel.